Good morning, all of you. Welcome to Sri Jayendra Rank Zone. So today we are going to discuss a new chapter, that is chemical kinetics. So already we have completed the previous chapter. We have done already electrochemistry. So now we are going to do chemical kinetics. Very important chapter. Let us start chemical kinetics now. So what are the things that we are going to discuss in chemical kinetics? Let us see now. So this chemical kinetics is nothing but it's a branch of physical chemistry which deals with the study of rate of reactions. Very important. It deals with the study of rate of reactions and the mechanism of the reaction. So that only it is called chemical kinetics. So chemical kinetics is a study of rates. Rates means with respect to time. So what is the rate means here? I'll just do it here. Here the rate means with respect to time, and velocity means speed. Speed, you know already what is velocity. Chemical reaction and the factors which affect these rates. So in this chapter we are going to do this. So on the whole, what is chemical kinetics? The branch of physical chemistry which deals with the study of rates of reactions, rates of chemical reactions, study of rates of chemical reactions, and also its mechanism. Mechanism means how the reaction takes place into consideration. So this is called basic idea of chemical kinetics. So what is chemical kinetics? It's a branch of physical chemistry which deals with the study of rates of chemical reactions and also its mechanism. In other words, chemical kinetics is the study of rates or velocities of chemical reactions and the factors which affect these rates. So, and the factors which affect these rates, RATs rates. Now we are going to discuss now. So let us take into consideration. So what are the factors which affect the rates of chemical reaction? What are the factors which affect the rate of chemical reaction? Let us see now. So what are the factors? First, we have the factor is nature of reactants. Depends upon nature of reactants. Reactions between ionic compounds. You know, ionic compounds means bond formed between metal and non-metal. So ionic compounds in solution tend to be faster than those covalent molecules. So if the reactants are ionic in nature, the reaction is faster. If the reaction is covalent in nature, it is a little bit slow when compared to ionic compounds. So why? Because ionic compounds, when you dissolve them in solution, they tends to be faster than those, because ionic compounds, when you dissolve them in solution, they form ions. They form cation as well as anion. So due to which what happens, that the reaction between ionic compounds in solution tend to be faster than those between covalent molecules. And covalent compounds does not soluble in polar solvents. Next, second point is presence of catalyst. So what does the catalyst will do? It always, if you have catalyst two types mainly, positive catalyst and a negative catalyst. So a positive catalyst increases the rate of reaction, whereas negative catalyst decreases the rate of reaction. So negative catalyst and positive catalyst. So negative catalyst decreases the rate of reaction. On the whole, what is catalyst? A catalyst is a substance which is not included in the chemical reaction, which does not involve in the chemical reaction, but only in the presence of catalyst, the reaction takes place. So that is nothing but the effect of catalyst. I hope what is catalyst already you know. Next, temperature. It increases. Increases in temperature, increase the rate. Means if you increase the temperature, the reaction rate also increases. So whether it is exothermic or endothermic depends also. But here, for the rate of reaction to proceed faster, so temperature should be more. Next, intensity of radiation absorbed in photochemical reactions. Higher the intensity of incident, right? Higher will be the rate of reaction. So what is the factor here? Higher the rate of incident light, higher will be the rate of reaction. So these are the four factors which are affecting the rate of reaction. So what is rate of reaction? The time taken by the reaction to complete is called rate of reaction. I hope it is clear. So rate of reaction depends upon four factors. First is nature of reactants. If the Reactants are ionic compounds, then the reaction takes place faster when compared to covalent compounds. Next, presence of catalyst. A catalyst will increase the rate of reaction, and temperature, increase in temperature increases the rate. And fourth one, intensity of radiation absorbed in photochemical reactions. Higher the intense photochemical reaction means what is present in the presence of sunlight. For example, hydrogen combined with chlorine in the presence of sunlight. In the presence of sunlight means UV rays. It forms 2HCl. It means what? In the presence of sunlight, this is called a photochemical reaction. So in this case, higher the intensity of incident light, higher the intensity of incident light, higher will be the rate of reaction. I hope it is clear. So this is called photochemical reactions. So these are the these are the factors affecting rate of reaction. Next, rate of chemical reaction. What is the rate of chemical reaction? As I told you, in general words, the time taken by the reaction to complete is called rate of chemical reaction. But in chemistry wise means here when you are going in particular deeply, it is a change in molar concentration of reactant. Already we know reactants will have concentrations. So it is a change in molar concentration of the reactant. Molar concentration of the reactant. Molar concentration is what? Molarity, which we have discussed in dilute solutions. What is molarity? Also we know that is number of moles by volume of solution liters. So molarity, capital M. So concentration, molar concentration of reactant or product with respect to time, that is per unit time. So the rate of reaction is equal to change in concentration of time of reactant by product by, so change in concentration of reactant or product by time taken. So units of rates is moles per liter per second, because unit of concentration is what? Moles per liter. Since moles per liter is a unit of concentration, so automatic time taken means per second, which also can be taken as moles per decimeter cube, because decimeter cube is equal to liters. So second in Celsius, and molarity per second, because moles per liter can also be called as molarity, that is capital M. And bars, atmospheres. If you take in consideration of pressures, you'll get atmosphere inverse, bars inverse. In gaseous reaction, pressure is proportional to concentration at constant volume and temperature. So this is called rate of chemical reaction. So in general, in general, rate of chemical reaction is the time taken by the reaction to complete is called a rate of chemical reaction. But here, actually, if you go into consideration, a change in molar concentration of reactants. Already we know if a reaction takes place, either reactant changes to product, means here what happens, the concentration of reactant should decrease and the concentration of product with the, should increase with respect to time, because as the time increases, reactant changes to product. So that's why the change in concentration of reactant or product by time taken is called as, generally is called as rate of reaction. So in this way you'll find rate of reaction. Next, types of reaction rates. There are two types of reaction rates, average rate and instantaneous rate. Both are very important. They ask us to calculate average rate or instantaneous rate for the examination, competitive exams like JEE mains and NEET, etc. So all competitive exams, this is very important. So what is average rate and rate of reaction? So we'll discuss now what is average rate and rate of reaction. Rate may be expressed with respect to a reactant or product. Average rate of a reaction is the ratio of the total change in the concentration of a reactant or a product to the total time taken by the change. So for example, you can see here, consider a reaction R changes to P. So here what happens, the average rate of reaction is the ratio of total change in the concentration of reactant, total change in the concentration of reactant or a product to the total time taken for the change. It is called as average rate. So average rate numericals are important that we are going to discuss now. So how to calculate average rate we'll see now. So let us consider reactant change to product is one chemical reaction in which R changes to P. That is reactant changes to products. Now, let concentration of R1 and P1 be the molar concentration of the reactant. Concentration, this bracket, square bracket represents what? Concentration. So concentrations R1 and P1 be the molar, let R1 and concentration of P1 be the molar concentration of the reactant. molar concentration of the reactant and product at time t1, and R2 and concentration of P2 be the corresponding concentrations at time t2. Now we can see two things here very very important. So first one is what? Reactants in a generally a chemical reaction takes place means first one, what are the things you have to see in a chemical reaction? First point, reactants will disappear with time. Reactants disappears disappear means the concentration of reactant decreases with respect to time. With respect to with the time. With respect to time. And second point is the concentration of reactant products. Concentration of products increases with respect to time. This is only happening because first the concentration of reactants start decreasing and the concentration of products starts increasing. So that's why we'll say average rate for the disappearance. We'll use the word disappearance because the concentration of reactant decreases. So that's why we'll use the word disappearance. So what is disappearance means? As the time increases, the reactant concentration of the reactant decreases. So this is nothing but as the time increases, the concentration of reactants decreases. So that is calculated as in terms of reactants, average rate of disappearance of reactants is equal to -1. Why you are using -1? Because always decreasing concentration of R takes place with respect to time. So that's why you'll use minus sign. And decreasing concentration of R -1 delta R by delta T, where delta is nothing but change in concentration. Decrease in concentration or change in concentration of R. This can be calculated by using the formula R2 minus R1 because initial it is R1 concentration, and after time t1 intervals what happens, it changes to uh, at t time at after time interval t2 it changes to R2. So R2 minus R1 by T2 minus T1, that is change in time taken. Time taken is T2 minus T1. So and in this case R2 should be always less. Anyway, always in this case R2 is less than R1 only because as the time increases the rate of concentration decreases. Concentration of reactant decreases. What decreases? Concentration of reactant. So always R1 is the initial concentration of reactant, R2 with the concentration of the reactant after time t2 seconds. So due to which what happens, you'll get the formula like this. And why you are using minus n? So that you'll get total positive value because R2 is always less than R1. So R2 minus R1 becomes negative and negative of negative becomes positive. Divided by time taken T2 will be always greater than T1 because after it is coming. So in this way, you'll calculate average rate of disappearance of reactants. What we'll call it as average rate of disappearance of reactants. Very, very important. So I hope it is clear. So in this way, you'll find average rate of reactant of disappearance of reactants, that is equal to -1 into R2 minus R1 by T2 minus T1 at two intervals they have taken. Next, similarly, the concentration of reactant decreases with respect to time, as we already discussed. Hence, R2 minus R1 is a negative quantity and minus delta R. That is nothing but minus delta R is a negative quantity. And it is multiplied by -1 to make the rate of reaction a positive quantity. So, to make the rate of reaction a positive quantity, we have to multiply with -1. So, rate of formation. Now, next we see how to find rate of formation of P. That is, P is called what? Products. And products will be formed, and rate of disappearance means reactants and formation is products. That is the only difference. So for reactants we'll see what? Disappearance, and for products we'll see formation of products. So for formation we'll use, for products we'll use the concentration of formation, which is increasing concentration of P by time taken. And already that is delta, that plus value you have to use because it is increasing concentration. So P2 minus P1 by T2 minus T1. So in this way we'll calculate the average rate of formation of products. This is called the formula for finding average rate of formation of products. And in this case, P2 is always greater than P1. And in the reactants case, R2 is less than R1. The position indicates that the concentration of P increases with respect to time. So I hope it is clear. In this way, you'll calculate average rate of reactions. So to calculate average rate of reaction with respect to reactant, It is nothing but decrease in concentration of reactant by time taken. That is change in time taken. You cannot say time taken. We'll say change in time taken also. You will say time taken also. It's same thing. So I hope it is clear. Next. So that's in general average rate is equal to delta C by delta T, where delta C is called change in concentration of the product or a reactant. Common is what? Delta C will, right? Because delta C can be C2 minus C1 by delta T means T2 minus T1. But delta C can be taken as either for the concentration can be taken either for reactant or product. For reactant, we have to use minus sign, and for product, we have to use plus sign. So that is the interval. And time interval is delta T. Next. Graphical representation, very important. You can see here, consider a reactant. This is the reactant and the time taken. So the graph is plotted between concentration of reactant as well as time taken. Now let us see. First, the reaction is at concentration R1. This concentration of reactant is at R1. So this value is the value at time t1 seconds. As the time increases, what happens? The concentration of reactant decreases. This shows the graph is decreasing graph. Decreases means what? The concentration decreases with respect to time. So this graph shows it is decreasing concentration. Decrease in concentration. Already, as we know, as the time increases, the concentration of reactant decreases and the concentration of products increases. So decrease in concentration of reactant takes place. So the decrease in concentration of reactant like this. So let us take after time t2, it is R2. So by this average, it is equal to minus 1 into delta R by delta t, which you already know the formula. So delta is nothing but R2 minus R1, where R2 is less than R1 and R1 is always greater than R2 because this is a starting value and this is a higher value. So I hope it is clear. So in this way, we will find out average rate for, this is the graphical representation of average rate in case of concentration of reactants. So graph representing average rate in case of concentration of reactants. So always a decrease in concentration of reactant takes place with respect to time, because as the reaction proceeds, the concentration of reactant decreases and the concentration of products increases. So the same graph, if you take for the formation of products, it will be increasing. So let us see that graph also now. So as I told you, it is increasing graph. Means as the time increases, the concentration of parts. So initially the concentration at T1 decrease at T1 time. So for example, after 5 seconds or 10 seconds, T1, it is concentration of a product is P1. Then after time T2, it increases to P2. Increases here, it is nothing but what? Increases. That's why you use positive sign, and P2 minus P1 with T2 minus T1. And always in this case, P2 is greater than P1. Again, I'm writing P2 is greater than P1. P2 is greater than P1. So that is concentration after time. So with as the time increases, the concentration of product increases. So this bracket means concentration, molarity. So the concentration of product always increases with respect to time. So that's why P2 minus P1 by T2 minus T1. In this way, you'll find average rate for the concentration of products. I hope it is clear. Very, very important this topic. First model in this numerical, in this chapter, you'll get numerical only first of all, and in that also we'll get more about different types of formulas. Now, instantaneous rate. What is instantaneous rate? Since we have completed average rate, now instantaneous rate. The rate of a given reaction is not a constant, so it changes with time as concentration changes. Hence, it is appropriate to use the word instantaneous rate. Instantaneous rate is defined as the rate of reaction at any point or instant of time during the reaction. So, instantaneous at any instant of time during the reaction, it is called as instantaneous rate, and it is also calculated by the same formula. Rate of disappearance of reactant is equal to minus dr by dt. So instantaneous means we'll use the value differentiation. So differentiation and delta, there is a small slight change in differentiation. This D represents differentiation. Differentiation, it is a mathematical word. So differentiation, that is also related to change. So differentiation and delta almost they are same, but slight difference is there. That difference we will not consider in chemistry. In physics, we'll consider the difference between differentiation and delta, but here we'll consider minus dr by dt, where differentiation of concentration of r by dt means differentiation of time. where dr is a small change in concentration of r during the small time interval dt. So I hope it is clear. So it is clear. So this is called differentiation. What is called differentiation? So instantaneous rate is nothing but minus dr by dt in case of reactants. Whereas parts minus in case of parts it is nothing but what? Plus dp by dt, where d of concentration of p by dt. So the negative sign implies that the concentration of r decreases with time, whereas the rate of formation of p is equal to plus d of concentration of p by dt, differentiation of concentration of p by differentiation with respect to time. So in generally, rate is equal to plus or minus dc by dt, where dc is called small change in concentration for a product or a reactant. So DC commonly we'll use what? DC. DC means either concentration of reactant or product during the time interval dt. Next, graphical representation of instantaneous rate. Instantaneous rate, how to represent graphically. A graph of concentration versus time is drawn for a reactant or product. A tangent is drawn to the curve at time t seconds. And so what is here instantaneous? We have to draw a tangent. What is a tangent is drawn to the curve. As we know, the curve for concentration of reactants it decreases like this, and for products it increases like this. So if you draw a tangent for this, tangent means the line intersecting. So for example, this is called the tangent, and for this also this is called the tangent. So I'll show you clearly the tangents. So a tangent is drawn to the curve at time t seconds. At the time at which the rate has to be determined, the slope of this tangent is equal to the instantaneous rate. So if you find the slope of the graph, it is nothing but instantaneous rate. So slope of this tangent, the tangent which you are going to draw for the curve, what curve? For the product and reactant. So that is nothing but here, if you can see here. So this is called, because let us see concentration of reactant, and this is time in minutes. First 0, it is 0, 0. After 5 minutes, what happens? The concentration of reactant decreases, means increases, means here it is 0 to 0 0.2 like this. Initially it is 1. So after 5 minutes, what happens? After 5 minutes, how can you see this graph? You can just see here. Let us say initial the concentration of reactant is 1 molarity. So after 5 seconds, how much it has come? It has come to, you have to draw this line. This line, if you want to draw, you can draw like this. After 5 seconds, that line draw. After 5 seconds, the concentration slightly decreases up to 0.6. So after 10 seconds, again, you can draw the slope. And it changes to 0.4. So 0.4. Next, after 15 seconds, this straight line actually I have to draw. So difficult to draw with the digital pen, but still it is okay. I hope it is clear to understand. Again, I'll draw this line. Take this line like this. So after 15 seconds, it is come to 0.2. So you can see the intervals. So average rate, how to calculate average rate, I'll tell you. Instantaneous rate. Already we have discussed average rate. Now we'll see instantaneous rate. So initially it was 1 molarity. After 5 seconds, decreases to 0.6. After 10 seconds, it decreases to 0.4. After 10 or 15 seconds, it comes to 0.2. So the slope is negative. So this is called the tangent line. And if you find the slope, that is equal to instantaneous rate, it's called dr by dt. For example, now if they ask you about instantaneous rate in between 5 to 10 seconds, 5 to 10 seconds, how to calculate instantaneous rate of this reaction between 5 to 10 seconds, then you have to take 5 to 10 seconds, means this is the interval. So initial concentration at 5 seconds is 0.6. So R1 is equal to, concentration of R1 is equal to 0.6, because we are not taking from starting, we are taking from 5 to 10 seconds, instantaneous. And concentration of R2 after 10 seconds is equal to becomes how much? 0.4. So 0.4, 0.4. I'll write it clearly. So again, I'll write clearly. Just please go through it clearly. So how to find instantaneous rate in between 5 to 10 seconds? From 5 to 10 seconds. So how to calculate? So in that case, concentration of R1 is equal to, after 5 seconds, it is equal to 0.6 approximately say. And R2, concentration of R2 is equal to it becomes 0.4, 0.4 time. Now instantaneous rate is equal to average rate means total we'll find, but instantaneous means how will you find instantaneous rate? You can just see here instantaneous rate is equal to minus of R2 minus R1, 0.4 minus 0.6. The formula is same by 10 minus 5 because T2 minus T1. T2 is 10 seconds and 10 minutes and T1 is 5 minutes. So you can calculate by using this. So this is called instantaneous rate between two intervals. Average rate means total will take, but instantaneous rate means this only. Average rate means what will take total it is 1, that is 1 minus, that is initial is 1 and total it has come to up to almost after 50 seconds almost 0.2. So R1 becomes for average rate what you'll get for average concentration of R1 becomes 1 and R2 becomes finally it is 0.2. So and time T2 minus T2 becomes 15 seconds and T1 is equal to 0. So 15 minus 0. So in this way you will calculate this is for average. So for both instantaneous and average I am showing the difference. Formula is same but intervals will change. That is concentration of R1 and R2 will change. This is R1, this is R2 in case of average for this diagram. Whereas this is R1 and R2 for this diagram in case of instantaneous rate. And how to find instantaneous rate? If you draw a tangent to the curve, which is showing decreasing graph, and the slope, if you find the slope, it is negative, and that is called the slope of this graph is called instantaneous rate. I hope it is clear. Very, very important this point. Try to understand. So even if you know this easily, you can solve numerical. So next, for products also, if you write tangent, this is called the tangent at T1, and this tangent for this product, and slope is positive. And here you can find out the instantaneous rate for this graph also. How to calculate instantaneous rate? Differentiation of products by time. Differentiation of time. I hope it is clear. Next. So what is the unit of rates of reaction? The concentration time inverse same moles per liter per second inverse for gaseous reaction because concentration per time is moles per liter per second. For gaseous reaction, concentration of gas expressed in terms of partial pressures. So in that case, it is atmosphere per second. Atmospheres per second. Next, rate when stoichiometric coefficients. If in a reaction, the stoichiometric coefficients of various reactants and products are not same, very important point. So here you have to write how to write rate equation. So if in a reaction, the stoichiometric coefficients of various reactants and products are not the same, then the rate calculated with respect to different reactants and products also will be different. In such cases, in order to give a single value to the rate of reaction, in order to give the single value for the rate of reaction, the rate with respect to a reactant or product is divided by its stoichiometric coefficients in the balanced chemical equation. For example, this is the reaction 2N2O5 gives rise to 4NO2 plus O2. 2N2O5 gives rise to 4NO2 plus O2. So here the number of moles of reactant is 2 moles of N2O5, where the product is 4 moles as well as 1 mole. So it's giving 2 when you take 2 moles of N2O5, that is dinitrogen pentoxide, we are getting 4 moles of nitrogen dioxide as well as 1 mole of oxygen gas. So let us see how to write rate equation for this. So the rate at which NO2 is produced 2 times the rate at which N2O5 is consumed and 4 times at the rate oxygen is formed and so on. So for this case, we'll take into consideration like this. And how to write rate equation? How to write rate equation? So to find rate of reaction, so rate is equal to for the reactants always we have to use minus sign because as the concentration as the time increases the concentration of reactant decreases, so we are keeping minus sign. And whatever the stoichiometric coefficient, for example, so in the previous slide you have seen 2N2O5, what is the reaction? 2N2O5, again writing here, gives rise to 4NO2 plus 1 O2. So 2 means taken as denominator minus 1 by 2 because it is decreasing, and number of stoichiometric moles should be taken as denominators. And next, NO2 is produced 4 times, 4 moles of NO2 is there. So that should be taken as denominator of 1 by 4. But you have to keep plus sign here, very, very important plus sign. And differentiation of NO2 by dt. These are all equated. So minus 1 by 2 differentiation of N2O5 by dt plus 1 by 4 differentiation of NO2 by dt plus DO2 by dt. This is the way of writing representation of chemical reaction, rate of reaction. So rate of reaction is nothing but the rate of disappearance of reactants is equal to rate of formation of products. What is the criteria here? Always the disappearance of reactant, rate of disappearance, this is called rate law. Rate of disappearance of reactants is equal to rate of formation of products. Rate of formation of products. Always this should be same. Then only the reaction proceeds. Rate of formation of products. So these two are most important. This is also called as, we will call it as rate law. What is this called? Rate law. So according to rate law, always the rate of disappearance, of reactants is equal to rate of formation of products. So in this way, we are using this, and the stoichiometric coefficients of the reactants or products should be taken as denominator. And more important, for reactant you have to use only minus sign but not the value, and for products you have to keep plus sign, because for reactants why we are keeping minus sign, because as the time increases the rate of concentration of reactant decreases, so that's why you keep minus. And for products, as the time increases the rate of concentration of products increases, that's why you keep plus. I hope it is clear. Now same example you can see. Consider reaction A moles of A plus B moles of B gives us C moles of C and D moles of D. So these two are reactants and these two are products. So minus 1 by A, small a is called coefficient, stoichiometric coefficient. Differentiation of A by dt is also equal to minus 1 by B differentiation of B by dt, which is also equal to plus 1 by C differentiation of C by dt plus 1 by D differentiation of D by dt. This is called, and these two are called rate of formation of, sorry, rate of disappearance of A or B, and this is called rate of formation of C or D. So rate of disappearance of reactant is equal to rate of disappearance of product. And the stoichiometric coefficient I have to keep down, denominator. So I hope it is clear. Very, very important, this type of expressions. Definitely they'll ask in examination. And this is applicable only for gaseous and liquids. Suppose if the in the reactants, for example, I'll show you an equation pattern. For example, one more example I'll write here. Calcium carbonate on heating strongly. This calcium carbonate is solid. On heating strongly forms calcium oxide. This solid plus carbon dioxide gas. So for this outright rate expression is nothing but, here it is already balanced. So rate is equal to, for this reaction rate is equal to 1 by differentiation of carbon dioxide by dt only, because for carbon dioxide no stoichiometric, that's why 1 by. So differentiation of concentration of carbon dioxide by dt. We cannot write for concentration. For solids, the concentration is taken as 1, that is unity. So the concentration for solids, there is no concentration. So we'll consider only for gas or liquids. So in this way, you are tried. Sometimes they'll give in the examination, wantedly they'll give solids in the reactants and products, and they ask us to write the rate of reaction. So rate is equal to differentiation of CO2 by dt only. In this case, only carbon dioxide. It is with respect to only formation of carbon dioxide. It is not with respect to disappearance of calcium carbonate, because rate of disappearance of calcium carbonate cannot be calculated, because for calcium carbonate no concentration is there. So that's why this is the answer. So like these questions are most important in the objective exams. So many times they ask it. Now let us consider this. So for this rate is equal to minus 1 by a differentiation of A by dt minus 1 by B, as I already explained you. So this is called rate of disappearance of reactants A and B, and this is called rate of formation of products C and D. Here see the terminology: rate of formation of product C, rate of formation of product D, rate of disappearance of reactant B, and rate of disappearance of reactant A for this chemical equation. I hope it is clear. So always the terminology is important. So if you know the terminology, what is the numerical they are given, you can apply it easily. So rate of formation of product and rate of disappearance of reactants. I hope it is clear. Next we'll proceed. Now let us see examples. Nitrogen dioxide combines with fluorine to form nitrosyl fluoride. This is the reaction. Write the expressions for rate of formation of NO2F. NO2F they are asking. So you can see here NO2F for directly formation they are asking. So I'm writing here rate of formation of NO2F. Rate of formation of NO2 means since it is 2 moles is equal to rate for first one rate is equal to plus because it is product 1 by 2 because 2 is their denominator differentiation of NO2F concentration of NO2F by dt. It is clear now. This is called first answer. Second, rate of disappearance of NO2. NO2 also 2 moles. Disappearance. So if our NO2 rate is equal to, this is second problem in this question. So rate is equal to, how to write? Minus 1 by 2. Why we are writing minus 1 by 2? Because as the time increases, the concentration of nitrogen dioxide decreases and the concentration of NO2F nitrosyl fluoride increases. So for nitrosyl fluoride, we'll keep plus sign because it is a product, and for this we'll keep minus sign. And 2 because it is against denominator 2 because it is 2 moles. Differentiation of NO2 by dt. Next, similarly, you can write for third one, rate of disappearance of F2. So rate is equal to, for third case, rate is equal to minus differentiation of, because number of moles of fluorine is 1. So no denominator, 1 by 1. So differentiation of F2 by concentration of F2 by dt. Because all are gases here, gas, liquid also you can write. But if they have mentioned solid here, we should not take that into consideration because for solids the concentration is taken as unity. So I hope it is clear. Let us see the answer now. Yes, differentiation of NO2F by dt, that should be minus 1 by 2 they have to write. They didn't write here, it is wrong. This is only correct. So here also I'll correct it. So for this one should be taken to 1 by 2. And for this also 1 by 2, minus 1 by 2, minus anyway is correct, but 1 by 2, and for this it is right, absolutely right. So answer is this. I hope it is clear. So this is not printed, somehow they have forgotten it, so that's why I have written it clearly. So in this way you have to write rate equation, rate for a given reaction. So rate of formation, rate of disappearance. I hope it is clear now. Let us see next question. So rate of formation, here they have to written wrong, they have written 1 by 2 plus we have to keep here, and for this minus anyway it is correct, but this is also 1 by 2 because they are given for nitrogen NO2 is 2 moles and NO2F also 2 moles, and for this 1 mole this is correct. Next question, very important. This type of questions are most important. They'll ask in the competitive exams. Very important. Simple it is. A chemical reaction takes place 2A plus 4B gives us to 2A gives us to 4B plus C. Means A is reactant, B and C are products. In gas phase. Gas phase is also important. Occurs in a closed vessel. The concentration of B is found to increase by 5 in 10 to the power of minus 3 moles per liter in 10 seconds. So they are asking calculate rate of disappearance of B. So they are given concentration of B is given in 10 seconds time also given. They are asking rate of disappearance of B. So it is simple. So rate of disappearance of B is equal to rate is equal to what you have to write here for this reaction. Rate is equal to minus 1 by 2 differentiation of plus 1 by B. No, we are discussing about B, so we'll write B. So before going to this, I'll just make it clear. So before going to this, first we'll write the rate equation for this entire reaction. For this reaction, if you write rate is equal to minus 1 by 2 differentiation of A by dt is also equal to plus 1 by 4 differentiation of concentration of B by dt, because plus 1 by 4 is the rate of formation of B, which is also equal to differentiation of concentration of C by dt, because for this there is no stoichiometric coefficient. Now they are asking the concentration of B is found to increase by 5 in 10 to the power minus 3 liters. They have given concentration of B in 10 seconds. Calculate rate of appearance of B. They are asking appearance of B. So in 10 seconds. So concentration is given how much? 5 into 10 to the power of minus 3. My time is given 10 seconds into 1 by 4, which is equal to, so 1 by 4. So they are asking, so this is into 4 we have to keep. So 20 in 10 to the power of minus 3. So this becomes 5 in 10 to the power of minus 3. If you calculate like this, you'll get the answer. So 5 into 1 and 10 4 is 40. 5 by 40 means 1 by 8. 1 by 8 again you have to divide it. So you'll definitely get the answer. Let us see what is the answer now. 5 in 10 to the power of minus 4 they have given, because 5 in 10 to the power of minus 3 by 10, 10 to the power of 3 minus, just only 1 by 4 you need not have to calculate. So just doing it clear. So 5 in 10 to the power of minus 4, because 5 in 10 to the power of minus 3 divided by 10. Next, rate of disappearance of A. A means how many times it is? Just 2 times. Just exactly half. Half of this, because this is 4 times, this is 2 times. So it's a 5 or half means in 5, half is how much? 2.5. So I think you understood this clearly. So if you find the rate of disappearance of B, you can find rate of disappearance of A also, because both are related by 2:4, that is 1:2 ratio. So if B is 1 and this should be 1 by 2. So answer, this is the answer. Clear? Next question. Problems on average rate and instantaneous rate. So the decomposition of N2O5 in CCl for solution at 318 kelvins has been studied by monitoring the decomposition of N2O5 in CCl for solution at 318 Kelvin has been studied by monitoring the concentration of N2O5 starting from 2.33 molarity N2O5. After 184 minutes, it is reduced to 2.08. So initial concentration is 2.33. So let us take this is R1, because they are asking decomposition of N2O5, and this is R2. And the reaction takes place according to the following equation: 2 moles of N2O5 uses 4 moles of NO2 plus O2. Calculate the average rate for the reaction per minute. For 1 minute, they are asking. So that is, what is the rate of production of NO2 during this period also. First, we'll find average rate. So average rate for this reaction is equal to minus differentiation of R2 minus R1 by delta T. Why you have to give minus n? Because decreasing. And for how much, this is R2 minus R1. R2 is given how much? 2.08. So that is minus 1 into 2.08 minus 2.33 divided by 184. So if you do this, you'll get the answer. And similarly for NO2 product, it is equal to, how to find product for NO2? NO2 means how many times? If it is 2, it should be 4. So if it is 1, this whatever the value into 2. What are the value of this into 2 with a positive sign. So I hope it is clear. Let us see now. See 6.79 10 to the power minus 4. So 6.79 10 to the power minus 4 is 2 moles. And sorry, for 1 mole. So for 4 moles means you have to multiply with 6.7 into 4. You'll get 2.72 in 10 to the power minus 3. So this is 2:4 ratio. So 6.79, 2.72. So I hope it is clear. So if you know this value, you can find out this value also by applying your equation. Next, for the elementary reaction 2A plus 3B gives us 3C. The rate of appearance of C at time is 1.3. Rate of appearance of C. Appearance of C means, what is the word keyword you have to use? Appearance of C means differentiation of C by dt is equal to how much? It is equal to 1.3 10 to the power minus 4. And that too, it is 1 by 3. Okay. Now calculate rate of reaction. So rate of reaction is, rate is equal to 3 into 1.3. So 3 into 1.3 you'll get. So 3 into 1.3 in 10 to the power minus 4 by dt. Time is given how much? 1 second only. So with respect to seconds, we can find out. Rate of disappearance of A. For this reaction, how to write rate? Minus 1 by 2. Differentiation of A by dt is equal to plus 1 by 3. Differentiation of C by dt. Because from the stoichiometric equation, 2A and 3C. So this is called rate of disappearance of A. is called rate of formation of C. So this is very, very important. I hope it is clear. If you substitute the formula, you'll get the answer. The final answer is 1.3 into 4 point, because it is 3 times, so 4.3 10 to the power minus 5, and this is 8.66 because it is almost 2 times, because 2 and 3, so 8.1 and 1 time, 1.5 time more, so 8.66 10 to the power minus 5. So I hope it is clear. Next. So with this, we are completed in this first presentation. We are completed how to rate of reaction and how to find average rate of reaction instantaneously. Let us see now next coming in the same session next class. Now, yes, next rate equation or rate law. So what is rate equation? It is an equation that relates the experimentally determined rate of reaction to the concentration of reactants raised to their stoichiometric powers or various powers. So this is called rate equation or rate law. Rate law is very, very important. So what is rate law? It is an equation that relates experimentally the rate of reaction to the concentration of reactants raised to various powers. For example, for this reaction, a, a only reactants only are considered. Very, very important rate law. Concentration of reactants only. So how to rate equation, rate law. Rate equation, this is a rate and is equal to minus dr by dt, that is with respect to reactants, and it is equal to, so it is proportional to concentration of reactants raised to the stoichiometric powers. So here for A it is P, it is Q, it is R. Actually they have given A, B, C, C. This should be given as P molecules of A plus Q molecules of B plus R molecules of C. Then you'll get the answer correctly. So for this reaction, this is the rate equation. So rate is proportional to concentration of reactants raised to their stoichiometric powers. And for removing concentration of reactant, for removing proportionality, we have to use constant. So that's why R is equal to K into concentration of reactants raised to their stoichiometric powers. So stoichiometric powers, let us say for example alpha. For this reaction, R changes to P. So R to the power alpha. This can be 1, 2, 3, 4, and so on, depending on the number of moles of this thing. So always rate of reaction or rate equation is proportional to R is proportional to concentration of reactants raised to their stoichiometric powers. And for removing proportionality, we have to use constant, that is called K. This is K is called, what is K here called? Rate constant. What is K? It is called as rate constant. So they'll ask us to find even K also in the numericals. So very, very important. Always rate of reaction is proportional to concentration of reactants raised to the stoichiometric powers. This is called rate law or rate equation. Very simple. Now let us see. The exponents P, Q, and R may or may not be same as the stoichiometric coefficients A, B, and C in the balanced chemical equations. So this form of equation is known as differential rate equation. So this form of equation is known as what? Differential rate equation, and where K is called proportionality constant, also called as rate constant. So velocity constant or specific reaction rate. So rate is equal to, if concentration of A is equal to B is equal to C is equal to 1, then rate is equal to K automatically, because rate is equal to K, because rate is equal to K into A to the power B, B to A, B, and C equal. So since it is equal to 1, so R is equal to K. I hope it is clear. Next. So rate constant of a chemical reaction is defined as the rate of the reaction when concentration of all the reactants is unity. Rate law is determined experimentally and cannot be written based on the balanced chemical equation. For example, the experimentally determined rate law for the equation C2H4 plus H2 gives rise to C2H6. So where rate is equal to only concentration of C2H4 if they are given. Experimentally determined rate law. So this is experimentally determined rate law, not based on stoichiometric equation. So That's what here I want to discuss. Rate constant of a chemical reaction is defined as the rate of the reaction when the concentration of all the reactants is taken as unity, and rate law is determined experimentally only and cannot be written based on the balanced chemical equation. Very, very important. Here rate law is based on only experimental quantity only, not by balanced chemical equation. So for this reaction, if the rate is like this is also correct. But we cannot write for the same reaction as like this. And for this reaction, if the rate is like this, we have to take rate should be like this only, not for number of moles of like this. So I hope it is clear. So it is purely experimental quantity. It's purely experimental data or experimental result. It is nowhere concerned with. It is nowhere concerned with balanced chemical equation. I hope it is clear. Next, in a reaction, the rate is doubled. Very, very important these conditions. If the rate is doubled on doubling the concentration of reactant, then the rate is proportional to first power of the concentration of the reactant. Obviously, because if R is proportional to concentration of A, we can write, because if rate is doubled, R is also doubled. If rate is doubled, the concentration of reactant also doubled. That is, A is also doubled. Then we can say it is R is proportional to 1 A power 1. If the rate is increased by 4 times on doubling the concentration of reactant, so if rate is increases by 4 times on doubling the concentration of reactants, then the rate is proportional to second power. So in this case, R is proportional to A power 2, because by doubling the rate, A is increased, by doubling the concentration, rate is increasing 4 times. So R is proportional to A power 2. I hope it is clear. Next, continuation. What is order and molecularity of reaction? Reactions can be classified based on their order and molecularity. So first we'll see order of reaction. It is nothing but very simple. Order of reaction tells us how the concentration of various reactants influence the rate of reaction at a given temperature. So order of reaction, chemical reaction is defined as the sum of the powers of the concentration terms of the reactants. Here you can see sum of the powers of the concentration terms of the reactants in the experimental determinant rate equation. It is called as, so, order of reaction. For example, let us see, for this rate of reaction is this: A power B, B power Q, C power R, concentration K into. Then the order of reaction is equal to P plus Q plus R. Simple. It is sum of the stoichiometric powers of the sum of the powers of the concentration terms of the reactants. So it is very simple to understand, and this is called order of reaction. The order of reaction can also be expressed with respect to particular reactant only. It is defined as the power exponent of the concentration term of the reactant in the experimentally determined rate equation. The above reaction is order of P in A and order of Q in B and order R in C. So order is an experimental quantity and cannot be obtained from the coefficients of the reactants in the balance. So this is also not depending on balanced chemical equation. So it is not depending on balanced chemical equation, only experimental quantity. So order and rate and order both are depending on experimental quantity. It need not necessarily be a whole number, it can even be a fraction or zero. That's why you can say order of reactions can be zero, fraction, or even whole number. So it is very, very important. That is called order of reaction. It is nowhere concerned with the number of reactant molecules, it is concerned only with the experimental data. For example, the rate law for the following reaction is H2O2 give plus 3 moles of iodine plus 2 moles of H plus gives H2H2 plus I3. For this reaction, the rate is equal to K into H2O2 into iodine minus. No 3 power 3. So order should be 1 plus 1 only. It is not at all depending upon balance stoichiometric coefficients. Only H2O2 I minus. That's all. So it is order is equal to 1 plus 1 is equal to 2. That's why I'm telling you clearly, order and rate are based on purely experimental data only. So we'll do more questions on order and rate so that you can understand clearly. Next, the order of reaction has to be determined experimentally. First condition. The order of reaction can be a whole number or a fraction or even zero also. It can be zero or even negative also, negative. So now let us see. The calculate the overall order of the reaction for which the rate expression has this. Just simply have to add these two, 1 by 2 plus 3 by 2. So if we add 1 by 2 plus 3 to find the order of a reaction, 1 by 2 plus 3 by 2 order is good because some of the stoichiometric powers of the reactant terms. So 1 by 2 plus 3 by 2 is, it is 4 by 2, it is equal to 2. I hope it is clear. So order is equal to, just adding. Next question. Types of order. So order of reactions we have zero order, first order, second order, third order, fractional order, pseudo first order, or pseudo unimolecular reactions. Let us discuss briefly all these things. So what are zero order reactions? These are the reactions. They'll ask examples. Which of the following is a example of zero order reaction? So these are the reactions in which rate of reaction is independent of concentration of the reactants. So if rate is proportional to concentration of reactants to the power 0, it is independent, then it is called a zero order reaction. They proceed with a constant rate. Example, catalytic decomposition of ammonia on the surface of platinum catalyst under high pressure. This is a zero order reaction. In this case, it is observed experimentally that rate for this reaction is proportional. This is the presence of catalyst surface. So decomposition of ammonia to form nitrogen gas and hydrogen gas. So ammonia is independent of rate. So rate is proportional to K to the n to the power 0. So it is nothing but rate is equal to K. In this case, rate of reaction is equal to rate constant K, and this is called zero order reaction because if the what are zero order reaction, these are the reactions in which the rate of reaction is independent of concentration of reactants. So if you take the plot between graph also, it is independent of concentration of reactants. You take concentration of reactants and time, take into consideration. This is called, this graph represents zero order because there is no decreasing or increasing. I hope it is clear. Next, second example, catalytic decomposition of hydrogen iodide on gold surface. 2 moles of hydrogen iodide gas in the presence of gold forms 1 mole of hydrogen gas and 1 mole of iodine gas. In this case also it is observed, here very important, observed the rate is independent of concentration of the reactant, that is hydrogen iodide. Next, certain photochemical reactions also, like in the presence of sunlight or gold, will form, I said no. This is the reaction they have given wrong here. I'll just write it clearly again for this reaction. You can write photochemical reaction H2 plus Cl2. In the presence of sunlight, it forms 2HCl. In this case also, rate is independent of, rate is equal to K into, for this reaction, H2 to the power 0 because it is not depending on concentration of hydrogen, neither hydrogen nor chlorine. So on the whole, this is the rate expression. So this is called zero order reaction, just like this. I hope it is clear. Next question. In a catalytic decomposition, only the molecules adsorbed on the surface of the catalyst. This absorption is prevailing on the outer surface, which we are going to discuss in surface chemistry. So what is adsorbed means prevailing on the outer surface only. Prevailing on the, absorbed is going inside, but prevailing on the outer surface. It is called adsorption, outer surface. So on the metallic surface, the gas molecules will be adsorbed on surface of catalyst like platinum, gold, etc. They undergo decomposition. So at high pressure, all the active sites are occupied by the reactant molecules, and the concentration of these adsorbed molecules is constant. Hence, the rate of reaction is also constant, and it is not at all depending on the reactant molecules. I hope it is clear. This is called the picture of zero order reactions. In a photochemical decomposition also, the rate of reaction depends only on the concentration of photochemically excited molecules, but not on the total concentration of the reactant molecules. The concentration of the excited molecules depends on the intensity of radiation absorbed, that is based on light. Next, first order reactions. For most the first order reactions, the rate of reaction is directly proportional to the first power of the concentration of reactant. Means rate is proportional to. Means if rate is doubled, concentration of reactant is also doubled. If concentration of reactant is doubled, rate is also doubled. So we can say that type of reactions are called as first order reaction. Just they are developed like this. And examples of first order reactions: ammonium nitrate on decomposition forms N2 plus water. So it is called first order reaction because in this case rate is proportional to concentration of ammonium nitrate and 2 moles of N2O5, even though it has 2 moles, but rate is proportional to only 1 mole because this is experimental quantity. So we should not see the balanced stoichiometric equation for rate as well as order of reactions. Very, very important point. Kindly note that. So PCl5 here also the same, here also the same. So these are the different examples of decomposition reactions. Certain decomposition reactions are examples of first order reactions. So decomposition of ammonium nitrate and decomposition of nitrogen dinitrogen pentoxide, phosphorus pentachloride, and hydrogen peroxide. I hope it is clear. Next, radioactive decay also follows first order kinetics. All radioactive reactions. That's why nuclear chemistry they'll simply follow first order kinetics. All nuclear reactions they are following first order reactions. So that is nothing but nuclear chemistry. So in nuclear chemistry, this chapter we have to extend in nuclear chemistry also. So nuclear chemistry they follow, that is radioactive disintegration. Always radioactive disintegration follows first order kinetics. Radioactive active disintegration, or you can say radioactive decay. Radioactive disintegration follows first order kinetics. Very, very important. So whenever they are given any radioactive element, we have to think it is first order. That's all, directly. And we can apply the formula based on first order kinetics. Second order. A second order reaction is a reaction whose rate is directly proportional to the second power of the reactant. Very, very important. Second power of the concentration of the reactant. So R is proportional to K to the power of A to the power of 2. K into concentration of A to the power of 2. R is equal to K into, that is rate constant K into concentration of A to the power 2. So if the reaction has two different reactants A and B, then the rate of reaction is proportional to the first power of the concentration of both A and B. Then also we can say it is second order reaction because on the whole the rate is expressed as K into A to the power of 1, B to the power of 1. So this is called second order reaction. So these are the two conditions. Next, examples of second order reactions, 2 moles of HI. So in this reaction, rate is proportional to K into H concentration of HI to the power 2. And for this also 2. For this it is 1 and 1. So it is again second order. For this again 1 and 1 second order. Like this we have so many reactions. I hope it is clear. Next, third order. So if this rate is proportional to K into A to the power of 3, we'll say it is third order, or A square into B, or A B into C also. All the three possibilities. 3 moles of reactant, or 2 moles of one reactant, 1 mole of second reactant, or 1 mole each of three reactants A, B, and C. Reactants only. Next, examples of third order reactions, 2NO plus O2 gives us to 2NO2. In this case, rate is proportional to K into NO whole square into concentration of O2. So 2 plus 1, 3. So in this case, order is how much? 3. So that's why 2 plus 1. Since order is equal to sum of stoichiometric powers of the reactants in the rate equation. So 2 plus 1, 2 plus 1. So I hope it is clear. So this is called third order reactions. So in this session, we have completed first order, second order, third order reactions. And also the first lecture, as we have done completely first lecture, also we have completed uh, order of reaction, average rate of reaction, how to calculate average rate of reaction, and how to calculate this thing. So in the next session, we'll continue with a new topic. And we'll do more numericals on this first session also. Thank you all. I hope it is clear. So next session, we'll continue with a new topic in chemical kinetics.